In this presentation, we're going to continue to solve equations, but they're going to be a little bit harder. They're going to be two-step equations, and we're also going to look at some equations that have two different variables in them. So let's suppose that we have the equation 2x plus 5 equals 9. So remember that my goal at the end of this problem is going to be to figure out what x equals. And we also need to remember, in order to get x by itself, we need to use the inverse operations. So we should be doing things to both sides of the equation. Now my preference in solving an equation like this is always to take care of the addition or subtraction that's on the same side as the x first. I do that because if you take care of the division and multiplication first, sometimes we forget that we need to multiply or divide every little piece of the equation. So I'm going to take the plus 5 and I'm going to remember that the inverse operation of adding 5 is to subtract 5. And right below that plus 5 I'm going to subtract 5, and right below the 9 I'm going to subtract 5 also. So I subtracted 5 from each side of my equation. My equation remains balanced. So I'm going to start from the left hand side again. I'm going to write 2x. Now that plus 5 and minus 5 is going to add up to 0. So I can write plus 0 if I'd like to, but it really kind of seems silly. Remember, my goal is to get x by itself, so to have plus 0 next to it is kind of going against my goal. And then 9 minus 5 is going to give me 4. Now my next step is to get rid of that 2 in front of the x. Remember that this is 2 multiplied by x, so the inverse operation of multiplication is to divide, so I'm going to divide both sides by 2. So 2x divided by 2, the 2 over 2 again is going to reduce to 1x, just like we've done in the past. That 1 is not necessary, so I can just write x. And then 4 divided by 2 is 2. So my equation, which has remained balanced because I kept doing everything to both sides of the equation, is x equals 2. My final equation. That is my solution for x. If I wanted to check it, I could go back into the original. 2 times 2 is 4, plus 5 is 9. 9 equals 9. So not only is my solution x equals 2, but I know that that's the correct solution. Let's try that again. So 13 equals 4x plus 1. Now I decided I wanted to make this a little bit trickier by moving the x over to the right hand side. Now really, the x being on the right or the left doesn't matter, but for a lot of students they like to see the x on the left hand side. So this is a very simple process of just rewriting the equation, and I'm going to take the two sides of the equal to sign and write them on opposite sides. So I'm just going to write 4x plus 1, and then my equal sign, and then 13. Now, remember, like I said earlier, we like to get rid of the plus or minus first. So the 4x plus 1, the inverse operation of plus 1 is to subtract 1. Subtract 1 from the other side also. So now I have 4x equals 12. My equation is still balanced. Now remembering that this is 4 times x, I'm going to divide both sides by 4. 4x over 4 is 1x. 12 over 4 is 3. So my solution is x equals 3. If I wanted to go back to my original, 4 times 3 is 12. 12 plus 1 is 13. 13 does equal 13. I know that this is a correct solution for this equation. Earlier I promised that we would take a look at an equation with two variables in it. So I have an equation 2y plus 3x equals 8. Now for this equation I would like to solve for y. So my goal at the end of this equation is to get y equals by itself. Now really this is the exact same process. Nothing about this process is going to be any different at all. I'm going to take care of the plus 3x first. Now the inverse operation of adding 3x, which is on the same side as that y, is to minus 3x. It does not matter that there's an x attached to it. What does matter is when I subtract it from the other side, I am not going to subtract it from the 8 per se. I'm not going to subtract it from the 8 and make it something like 5 or 5x or anything like that, because 8 and 3x are not like terms. So on my left hand side, I'm now left with just the 2y. On my right hand side, I cannot combine those terms. They are not alike, so I'm just going to write 8 minus 3x. Just going to write them right next to each other. And by the way, if you look at the previous step, that's why I wrote the minus 3x over to the right of the 8 rather than directly below it. Now I still have the 2 times y, so I need to get rid of that 2. So I'm going to divide both of my sides by 2. I'm going to divide the left hand side by 2. I need to divide the right hand side by 2. Now there are 2 terms on the right hand side, so I'm going to have to divide each of them by 2. So on the left hand side, 2y divided by 2 is going to leave me with that 1y again. Now on the right hand side, I'm going to treat each of these 2 terms separately. So 8 divided by 2 is going to leave me with 4. Negative 3x divided by 2. With division, it does not have to be like terms. We noticed that earlier when we were dividing 2y by 2, and we could still divide it, even though the 2y has a y and the 2 does not. 3 is not divisible by 2, so I'm just going to write this as 3 over 2x. That's a very helpful way to write an equation in slope-intercept form, which is one of the major ideas behind solving an equation in 2 variables.